This is something new for my channel, but I think it does a good job of showing what I do at work. I thought it would be a good idea to strap a camera to a hat, so come along while my boss and I do some overnight transmitter maintenance. Tonight, we're working on a Harris HPX 30 FM transmitter. This was the last vacuum tube-based rig designed by Harris Broadcast before the Flexiva line of solid-state transmitters was introduced. This one is kept as a cold spare backup for one of our radio stations. Our department has a policy of running every non-full-time transmitter we have at least once every 3 months, and this one recently came due for a checkup.
Of course, this guy is still not responding. It does have power now, which is okay.
This component is the TCU, or Transmitter Control Unit. We have the optional advanced touchscreen interface, but as you can see, it doesn't work. We can still access it through a web interface, as you'll see later.
Alright. Cool. Alright, I'm going to kill the exciter. Alright. I'm going to pull this breaker to turn the rest of the stuff off. Alright, cool. Alright, what do you say we take a look at the back of this guy? Oh, I need a key.
This is called a grounding stick, but most people call it a Jesus stick for obvious reasons. It's a way to short components that may still be carrying deadly voltage to ground before touching anything inside.
These filament leads here. Uh-oh, hooked on something. There we go. Alright. I need a screwdriver. Actually, I'm going to grab this light too while we're at it.
Grab the light, grab the screwdriver, hand screwdriver.
Oh, okay. Hey! Hand drive screwdrivers. Perfect. Well, I'll use that one. Yeah, I'll use that one.
Here I've started the process of opening the tube cavity. It's an electrically resonant cabinet that houses the vacuum tube and the connection point of the main RF output from the transmitter.
Thank you.
It's also a good idea to use the grounding stick before touching anything in here as well. This large cylinder that's held in place by these clamps is what connects to the tube's anode, usually called the plate. For this 4CX 20000 tube, the entire outer surface of the top half is the anode contact.
There she blows. Magic mushroom. What do you think?
As you can see, this tube has seen some discoloration over its service life due to the massive amounts of heat it dissipates while in use. New tubes typically have a shiny aluminum surface.
The fingers on the thing, that definitely looks like insufficient cooling.
If you hadn't noticed already, I don't think either of us had seen a tube in such a weathered state, and Red has been in broadcasting for a while. He's taking pictures to ask Gates Air engineers if we should be concerned. The support engineer who called us back said this is typical for a tube in analog and digital hybrid mode after some time. The HD radio capable exciter we normally use in this transmitter is out for repairs, so we can probably retune the transmitter for the narrower analog only bandwidth we're currently using.
So you think we should run on this or replace it?
I don't know. I don't know about running on it.
Yeah, because when I came up in May and opened this up, like, I was like, that doesn't look as good as the other one.
And I would think if it was rebuilt in the past couple of years, it would look that.
No, you'd think they'd sand this off or something.
Yeah.
I mean, it's even in the cooling fins.
Yeah. That's why I was thinking, sure to get the angle here, but you can see the, you know, and even, you know, like, the fact that someone just like, how much of that is.
Yeah. Well, if you look at the notch filter down here, like you can even see like some soot blown out of the
Yeah, like,
seams there.
yeah. So, I'm gonna actually take a full picture of this. And this may be a good, you know, well, this will put back here.
But yeah, I saw that and I was like, I don't like that. But I also wanted to get you to see it before we even turn this on.
I
But
mean, I'm sure we could run on it, you know, and it would
Yeah.
be fine.
yeah,
But if it's already, you know, kind of.
yeah. If I do a PA disable on this, will it still run the blower?
It may if Mox isn't happy.
Because I wonder if we can do a PA disable so where it doesn't light up the tube, but it will still run the blower and we can check airflow. And this is still hooked up to the dummy load, so we can do testing on that without disrupting anything. But yeah, not a huge fan of that.
Even, you know, you're talking here, like,
Yeah.
this probably wasn't when this was done. So how much of that is just
Well, what's really funny is, like, you see the markings on the anode here. You kind of see the same markings on the inside of this,
Yep, you see that corresponding.
like where it flares up.
Yep,
Yeah.
makes sense. Because all here.
Uh-huh. Okay.
Yeah.
So,
Also should not.
yeah, it's probably not. Yeah, we've got some dead bugs.
Mouse droppings.
Oh yeah, and mouse droppings. Great. Yeah, okay, I'll put this back together and I'll look up the PA disable procedures just to refresh my memory, because I know we did it when we took IPA to air on the other HPX.
Well, you look that up, I'll back.
Okay. Okay.
In broadcasting, IPA isn't just a hoppy beer. In this case, it's an initialism for intermediate power amplifier, which is an amplification stage between the exciter and the tube. These HPX transmitters actually use power amplifier modules from the Platinum Z series, which was the solid-state offering from Harris at the time as the intermediate power amplifier.
All right. There we go.
Plug it in, but run it outside first.
Oh yeah.
Just without a notification, I want to talk out it.
Right. You have a tray with the screws for the cavity in there? Cool, thanks. Yeah. Okay, so we'll just do exciter to air.
Having the correct technical manuals for your equipment is essential when working on such sophisticated gear. If you need a manual or a service bulletin, the support engineers with the transmitter manufacturers are usually great at pointing you in the right direction. It also helps that they tend to be gigantic nerds just like us.
And then PA filament, cavity blower. We want the blower to run. So I'll leave cavity blower on. PA filament and screen. Okay. So kill those for when we reapply power. Alright, PA disable is disabled, and then PA filament, screen bias A, screen bias B. Okay. Well, let's close up the back, and then you guys, it's all vacuumed out?
Yep.
Okay. Sorry, I got my... November 28th, 2011. Can't believe this transmitter's only 11 years old. Alright, so I did turn off filament, right? Filament, screen bias A, screen bias B is off, cavity blower is on because we want to test that. PA disabled. Alright, cool. Make the electrical people happy.
Definitely a very union throw.
It's a union throw, yeah. Why isn't this on yet? Oh,
UPS.
nope. Alright. I can't remember if I was supposed to turn both of those back on. The right one stays on?
Double check.
Yeah, power supply cabinet control should be off.
I believe that's right.
Yeah, power amp cabinet AC should be on. Power supply cabinet control should be off. So this is probably what powers up this part. Power supply cabinet control is probably what brings up the IPAs and the bias and screen supplies, or at least this breaker. Okay, so the blower is on, PA is disabled. I'll turn off the IPAs too, just because I don't want this to fold back. Alright, well, here goes nothing.
The PA disable procedure we just performed allows engineers to bypass the tube and even the IPA for troubleshooting. There's a patch cable inside the cabinet that allows you to connect the exciter or the IPA directly to the transmission line.
Well, no, it's a web browser. It's a web page. So let me see here. Let me look in Cincinnati Engineering, documents, port info.
It's like, if you get the IP address, you can throw a label on it. So you get the screen first.
10727.
This web page is an approximate representation of what the touchscreen would look like on the transmitter.
PA disable, that's good. I mean,
Can you take your filament on from there and watch your meters?
oh. This is expected because the
Yeah.
IPAs are disabled. Yeah, nothing. Well, we might just have to enable the tube and turn the filament on for a couple of minutes to just make sure there's airflow coming out of the stack.
Yeah.
Because it should be pretty robust.
Yeah.
Okay.
Yeah. And that won't do anything further.
Yeah. Because especially if we're going to run it for only a couple of minutes.
We're just being cautious now, but it'll be fun. And it's
Yeah.
not like we're going to be putting it in here, you know.
Right. Yeah. Okay. So, IPA, filament, screen bias A, screen bias B, PA enable. Yeah, because we don't need to apply plate voltage or anything.
I mean, and honestly, when we contact Gates here, Walter, he's going to say, what happens when you try to bring it up? You know, like, is it full back or not? You know, like, so.
Okay, well thankfully we have the multimeters even though that front panel doesn't work. All that bottled water. Okay, well, do you want me to light it up or do you want me to get on the ladder and check the stack flow? Okay.
This is where I have to start muting the audio for copyright reasons. The radio station has copyright money, that's how we play music, but I don't.
Alright, you ready for me to hit filament or wait? Alright. You got airflow? Alright. Let me look at my filament voltage. Auxiliary transmitter is on
To switch between the main transmitter and the backup transmitter, we need to bring up the auxiliary transmitter first before turning the main transmitter off. This unit is directly connected to its own separate antenna on the tower, so we can run the antenna switch to put the backup transmitter on the primary antenna. In broadcasting, nothing is ever switched under power. If we moved that antenna switch under power, it would trip the safety interlock and shut off any transmitter connected to it. I'm bypassing the interlock on the auxiliary transmitter here in order to ensure it doesn't turn off. It's not connected to the antenna switch, but I was unsure if it was on the same interlock loop. Of course, it goes without saying, I'm a professional. Don't go disabling interlocks on broadcast transmitters.
Once the next song starts, I'll fire this. Actually, I can probably go ahead and turn on the filament just to warm up.
On these tube-based transmitters, you need to give the filament a few seconds to warm up before applying plate voltage. Once the plate is energized, the transmitter begins sending RF power to the transmission line.
Yeah, they really should have lowered that filament voltage. So now, filament's on. Let's plate on.
Once the backup transmitter comes up to power, we can shut off the auxiliary. At that point, we've successfully moved the radio station to another transmitter.
Alright. It's running 13,000 volts on the plate. It's running 13,000 volts on the plate. The HPX at Highland only runs like 9,000. Let me pull up the web page and look at the Bizwire reading.
That strange word I just used is spelled VSWR, which means voltage standing wave ratio. It's a measure of how well the antenna is radiating the RF energy sent to it. A perfect reading is 1-to-1, but that's infeasible in the real world.
I mean, it's 21.5. Bizwire's 108. Yeah, 108 to 1.
1.08 to 1 is not perfect, but it's close.
That stack temp is way hotter than
The stack temperature is reported by a probe at the mesh panel where the exhaust air leaves the top of the transmitter. Our other tube rig reports a stack temperature of 120 degrees Fahrenheit, or about 49 Celsius, at full power. This one was reading 160 degrees Fahrenheit, or 71 Celsius, and rising.
Yeah, that's pretty warm. Yeah. Yeah, we don't want to run that for too long. Alright, next song starts, we'll move it over. Yeah, that's... like, it's still going up.
That's crazy.
Yeah, that shouldn't happen.
After taking a screenshot of the various meter readings from the backup, we're ready to go back to the main transmitter. To do this, we run the same procedure we did earlier in reverse. Power up the auxiliary, turn the backup off, move the antenna switch, turn on the main transmitter, and turn off the auxiliary.
Give it a few seconds to sync up. I can't believe that's still going up.
Talking the refresh rate.
It's kind of topped out at 165. Close the back panel of this before I turn it on again. Okay. Alright, WREW, use low power. I can run that for a couple of minutes. So that's just from having plate on, because with just filament...
After turning off the plate voltage, the stack temperature reading was rapidly decreasing. Now, the filament in a tube this big is essentially a space heater packed inside the envelope, so the fact the temperature was going down so fast was surprising.
Yeah. Let's see where it settles with just filament. Let's see where it settles with just filament. Actually, while we're waiting on this, I can reboot the importer. Looks like it stabilizes at 85 degrees without plate on. Alright, well. Oh, yeah, I can't turn it off when I'm not logged in. Alright, give that a couple of minutes.
The HPX transmitter will keep the blower going for a minimum of 5 minutes after you turn the filament off.
like almost 14,000 volts on the plate. That's way too high.
I wonder if it's just way out of tune, you know?
Yeah.
This is not throwing any other errors. Like something is out of whack. It's making me up outside of it.
Yeah.
Either those are, I don't want to call them true hours, but they've been, that's low to or it's out of whack.
Yeah. I mean, everything else looks like it's okay. Save for the plate voltage and the stack temperature. Actually,
I guess points to failing food.
yeah, that's also true. Let me calculate efficiency on that.
The transmitter's efficiency rating is the percentage of grid electric power being consumed by the transmitter that is being converted to RF.
It's pulling 34 kilowatts of power off the grid to make 21.4 kilowatts RF.
You can get a rough estimate of this by dividing the output RF power into the product of the power amplifier's voltage and amperage.
You look at the electric meter when 34,149. Okay. That's a 62% efficiency. Yeah, running in FM only mode, that should be way higher. Because I think we got 90% out of the HPX at Highland.
Yeah, it looks like you're getting 72 out of this instead.
Yeah. Once that filament, once that blower shuts off, actually I can probably run the antenna switcher now. Is the interlock still bypassed on the Z10?
Yes.
Okay.
Once again, I'm a professional. Don't bypass the interlock on a broadcast transmitter.
You know, I'm not going to do it here. I'm going to do it here because I want to make sure that that's done right. So, all right. Cool. All right. So let's see if the importer is rebooted.
This is where I turn on the main transmitter, and once it comes up to power, I go over and turn off the auxiliary. It really is a shame I have to mute the audio here. Hearing the FM capture effect on the radio tuner in the room as you're switching transmitters is one of the coolest parts of the job.
So what do you think we should do? Like wait and see what Walter says and then come back and run this into the dummy load and see if we can tune it any better, or...
Yeah, and I'll check with Conco and see when the last
rebuild of that tube was.
Yeah.
Yeah, that's the only thing I'm worried about, because if Econco says it looked fine when it was rebuilt and it needed to be tuned, then that tube's probably already damaged and it'll need to be rebuilt.
Yeah, I'm already banking on something like that.
Oh yeah. Alright, cool. External interlock, I expect that because I switched the antenna. Alright. Well, No issue with the logo file, so that's good. It kept what I sent to it. Be like.
Thanks for watching this video. My goal is to give you a look behind the scenes of broadcasting so you can explore it as a career path if you're interested. If you want to see more stuff like this, let me know. I'll catch up with you next time.